Hello students, இப்போ நம்ம exercise problem பார்த்தலாம். See here, example 2.3 given at the page number 62 of exercise 2.4. The problem is you have to convert this 3 plus 4i by 5 minus 12i into the standard form, rectangular form x plus iy. Therefore, whatever be the number, you have to write this complex number into the rectangular form. Means we must have this imaginary unit only in the numerator, not in the denominator. Therefore, we can write this as let z is equal to 3 plus 4i by 5 minus 12i. This is set value. Now, in the denominator, we should not have this side. This is to be removed. Therefore, how do you remove? If it is 1 by means, we can write Darcy shortcut method. But here, numerator also we have some complex number. Therefore, we want to remove this I in the denominator means you must multiply and divide by the conjugate of the denominator. Therefore, you can write 3 plus 4i by 5 minus 12i into the conjugate of the denominator is 5 plus 12i by again 5 plus 12i. 5 plus 12i. Okay, now if it is like this, you can multiply the numerator by usual method. 3 5s are 15, then plus 3 12s are 36i, then plus 4 5s are 20i, then plus 4 12s are 48i square by, now this is of the form a plus b into a minus b. A plus b into a minus b means, I'll tell you here, see here, z into z bar means, if you consider z as x plus iy into z bar is x minus iy. If you remove this bracket, you can get x into x, x square, then minus ixy, then you take this plus ixy, then minus I square y. Now if you simplify this and this getting cancelled, you can get x square, then I square is minus 1, minus I square is plus 1, then you will be getting plus y square. Therefore, whenever you want to find z into z bar, it is enough if you find the sum of squares of real part and imaginary part. Likewise here, z into z bar or z into z bar means just what you have to do, you need not bother about this side, just you square the real part and imaginary part, then you add them. Therefore, here you can write 5 square plus 12 square. You need not bother about this one. You don't think this is a plus b into a minus b equal to a square minus b square means that is wrong, because can b square is I square is coming, therefore you can minus I square means plus I square. Likewise, you can write now which is equal to, and add 15, this is minus 48 because I square is equal to minus 1. Then here sum of these two becomes plus 56i by 25 plus 144. 25 plus 144. Now after that, try to simplify. See, 15 minus 48 is equal to minus 33, then plus 56i by 169. Now this is in the standard form, or this can also be written as 1 by 169 into minus 33 plus 56i. Likewise, we can write the result. Let us see the next problem. It's 2.4 given at the page number 65. You have to rewrite this complex number into the rectangular form. Now it is not in the rectangular form. See here we have sum of two complex numbers. Then you have to take the conjugate. For that, what is the given number? You can assume as z. Let z is equal to 5 plus 9i plus 2 minus 4i. This is conjugate of sum of two complex numbers. We know the property, conjugate of sum of two complex numbers can be written as the sum of their conjugates. See here, 5 plus 9i plus 2 minus 4i. Conjugate of these two things we can write separately. Now the conjugate of this one is 5 minus 9i, then plus. Conjugate of this one is 2 plus 4i. Now add these two things, 5 plus 2, 7, minus 9 plus 4 gives minus 5i. This is the rectangular form of this given problem. Now let us see the second solution. The second solution is 10 minus 5i by 6 plus 2i. Now this is the second solution. Yes, now this also can be brought into the rectangular form. This you can do as I have done that example 2.3. Now let us go for the next problem, third solution, that is 3i bar. This is for your homework. Third solution is given as 3i bar, then plus 1 by 2 minus i. 1 by 2 minus i. Now we have to write this in the rectangular form. For that we can name it as z. Let z is equal to 3i conjugate of 3i plus 1 by 2 minus i. Now conjugate of this 3i is minus 3i because you have to change the sign of the imaginary unit. Then plus, see this is the inverse of 2 minus i. We know very well z is equal to x plus iy means 1 by z is equal to iy by x square plus y square. Now this can be taken as z means, how do you find this one? 2 plus I, changes, take its conjugate and square the real part and the imaginary part. It is 2 square plus 1 square. Now which is equal to minus 3i plus 2 plus I by 5. Now you can take LCM equal to minus 15i plus 2 plus I by 5 you can write. Now which is equal to 2 minus 14i by 5. Or you can write this as 2 by 5 minus 14 by 5i. You can express like this also. Or you can write in this method, it is 1 by 5 into 2 minus 14i. We can follow this method. Given at the page number 65, if z is equal to x plus iy, now we need to find the values of these three problems. Now let us see the first one, real part of 1 by z. Here given z is equal to x plus iy. Given z is equal to x plus iy. Now we need to find the real part of 1 by z. Therefore first you have to find 1 by z. 1 by z is equal to, how do you find shortcut method? Just take its conjugate, x minus iy. Then square the real part and the image part, find the sum. You can write x square plus y square. Now this can be written as x by x square plus y square minus I into r plus I into minus y by x square plus y square. Now this is in the rectangular form. After writing in the rectangular form, we can find the real part of 1 by z. Therefore, real part of 1 by z is equal to, this is real part, this is imaginary part. Therefore, we can take this x by x square plus y square. Now this is the real part of 1 by z. Now likewise we can find out the, for second solution, real part of I into z bar. Now first let us find I into z bar. I into z bar is equal to I into, what is z bar? X minus iy. X minus iy. Now which is equal to, you multiply inside, you can get ix, then minus I square y. Now this I square value is minus 1, I square value is minus 1. Here I square is equal to minus 1. Yes, therefore we can say this is minus 1 is going to get ix plus y, ix plus y, but this can be written as in standard form y plus ix. This is I into z bar. Now we need to find real part of this I into z bar. Therefore, real part of I into z bar is equal to real part of this one is y. That's all. Yes. Now likewise, let's go for this problem. Here also, find imaginary part of this one means try to find the value of this expression. Then after bringing this into rectangular form, then we can easily find what is imaginary part. Therefore, we can find the value of this one. 3z plus 4z bar minus 4i, which is equal to 3z means 3 into z is x plus iy. X plus iy. Then 4 times z bar plus 4 times z bar means x minus iy. Then minus 4i. Now try to remove the bracket, which is equal to 3x plus I into 3y plus 4x minus I into 4y minus 4i. Now here we can add only real parts. 3x and this 4x are the real parts. Then we can write as 7x. Then plus I into, here you can write 3y minus 4y minus 4. Now this can be written as 7x plus I into minus y minus 4, because 3y minus 4y gives minus y. Now it is in the rectangular form. Therefore, imaginary part of 3z plus 4z bar minus 4i is equal to, this is real part, we need only imaginary part, is minus y minus 4. That's all. Now, at the page number 65, exercise 2.4 only. Here, for these two complex numbers z1 and z2, we need to find the inverse of z1, z2 and z1 by z2. Therefore, first try to find the product z1, z2, then we can find its inverse. Therefore, the first subdivision is inverse of z1, z2. This we are going to find out. Therefore, first you have to find z1, z2. z1 into z2 is equal to, z1 is 2 minus I into z2 is minus 4 plus 3i. Now which is equal to ordinary multiplication, 2 into minus 4 minus 8, then plus 6i, then plus 4i, then plus 3, we can say. Why means this is minus 3i square equal to minus 1, there we can write what? Plus 3. Now which is equal to minus 5 plus 10i. This is z2. For this you have to find inverse. Therefore, z1, z2 inverse. This is nothing but 1 by z1, z2. That is 1 by z1, z2 means this is equal to 1 by, what is z1, z2? Minus 5 plus 10i. Minus 5 plus 10i. Now how do you find this value? Just as I told them, 1 by means just you can take its conjugate, that is minus 5 minus 10i by sum of real part square and imaginary part square. This is minus 5 the whole square plus 10 square. You do not take a I. Therefore, this will be minus 5 minus 10i by 25 plus 100. You can get 125. Now, if you simplify this one, minus 1 by 25, then minus 2 by 25i. Now we have written this the inverse of this one. Okay, likewise, let us go for finding the second subdivision. The second subdivision, inverse of z1 by z2. Therefore, first let us find z1 by z2. z1 by z2, which is equal to, z1 is 2 minus I by z2 is minus 4 plus 3i. Minus 4 plus 3i. Yes, now want to in the numerator and also now we have I means this I is to be removed by multiplying and dividing by the conjugate of the denominator. Therefore here also we can write minus 4 minus 3I by minus 4 minus 3I. Now numerator is ordinary multiplication, minus 8, then minus 6I, then plus 4I, then plus 3I square means minus 3 you will be getting by, this is a plus b into a minus z into z bar means real part square plus imaginary part square. Therefore you can write minus 4 square plus 3 square, now which is equal to minus 8 minus 3 minus 11 minus 2I by, this will be 16 plus 9 25. 16 plus 9 is equal to 25. This is z1 by z2. z1 by z2. Now for this we need to take conjugate. Therefore z1 by z2 whole inverse is equal to 1 by this one minus of 11 plus 2I by 25. Now this can be written as minus 25 into 1 by 11 plus 2I. This can be written like this, 1 by. Now this is 1 by means as I told, you can write its conjugate in numerator and denominator, square the real part square and imaginary part square. Therefore that will be is equal to minus 25 into 11 minus 2I by 11 square plus 2 square. 11 square plus 2 square. Now if you consider this one, which is equal to minus 25 into 11 minus 2I by 121 plus 4, 125. 125. Now these two can be cancelled. If you cancel, I will give you how many times? 5 times. Therefore this will be equal to minus 11 by 5. Then minus into minus plus 2 by 5I. This is the inverse of z1 by z2. That's all. Let us see the next problem. For this expression, u, v and w are related by 1 by u is equal to 1 by v plus 1 by w. Now, if the values of v and w are these two things, then we need to find the value of u in the rectangular form. Therefore, 1 by u is given, there is given 1 by u is equal to 1 by v plus 1 by w. Now, for these two values of v and w, we need to find what is u. Therefore, first we can write 1 by v means 1 by 3 minus 4i plus 1 by w means 1 by 4 plus 3i. Now, here these two are reciprocals of this 1 by. Therefore, if you have, whenever you have 1 by, you try to write conjugate, that is 3 plus 4i by real part square plus imaginary part square means 3 square plus 4 square plus here also 1 by. Therefore, you can write conjugate 4 minus 3i by 4 square plus 3 square. Now, this can be written as 3 plus 4i by 25 plus 4 minus 3i by 25. Now, these two components have same denominator. We can add numerator, we can write as 25, then 3 plus 4, 7, then 4i minus 3i gives plus I. This is 1 by u. 1 by u. Now we need to find the value of u only. If 1 by u is equal to 7 plus I by 25 means u will be reciprocal of this one. Therefore, u is equal to 25 by 7 plus I. Now, this could be written as 25 into 1 by 7 plus I, or else you can directly take conjugate. You multiply and divide by its conjugate, 7 minus I by 7 minus I, which is equal to 25 into 7 minus I by z into z bar gives always real part square plus imaginary part square. You can write 7 square plus 1 square which is equal to 25 into 7 minus I by 49 plus 1 50. Then if you simplify, you will be getting 1 by 2 into 7 minus I, or you can write as 7 by 2 minus 1 by 2 I. Now this is the value of u, like this you can write. Positive integer n for which root 3 plus a whole power n is real and purely imaginary. That is, you have to find for what value of n, that is n value must be very small. For what smallest value of n, this is real, and for what value of this n, this will be imaginary. That you have to check. For that, we can give the values for n one by one. Then we can find the when it is real and imaginary. Therefore, first let us consider root 3 plus I whole power 1 means the same value, root 3 plus I only. Therefore, you can find the root 3 plus I whole square. This is a plus b, the whole square means a square, root 3 square, plus 2ab means 2 into root 3 into I, then plus I square. Now it is equal to root 3 square is 3 plus I into 2 root 3. I square value is minus 1. Therefore, we can get 2 plus I into 2 root 3. Here also you can take 2 commonly outside, then you will be getting 1 plus I root 3. 1 plus I root 3. Now this is root 3 plus I the whole square. Next we can find a cube, that is root 3 plus I whole cube is nothing but root 3 plus I into root 3 plus I the whole square. Now we know the value of root 3 plus I, that can be replaced, that is root 3 plus I into 2 into 1 plus I root 3. 1 plus I root 3. Now you multiply these two things. Just you can take this 2 here. Then you multiply these two things. Root 3 into 1, root 3. Then plus I into root 3 into root 3, 3. Then plus I into 1 equal to I. Then plus I square root 3. Now 2 I have taken outside, therefore number. Now we can write this as, which is equal to 2 into root 3. This is plus I 4 or plus 4I. Plus 4I you can say. Then here I square is minus 3. Minus 1 into root 3 minus root 3. Now these two getting cancelled. Then we will be getting 2 4s are 8I. That is root 3 plus I the whole cube is equal to 8I. Now here there is no real part, hence we can say it is purely imaginary. It is purely imaginary. Therefore, we can say the value of n equal to 3. Therefore, if n equal to 3, this root 3 plus I whole power n is purely imaginary. Purely imaginary we can say. Okay. Now likewise you have to check when it is purely real means, see here I is here. If you square this one, you can get the I square. I square is minus 1 means you will be getting only real part. Therefore, just you can square off, consider the square of root 3 plus I whole cube. That is root 3 plus I whole cube is there. You square it, which is equal to 8I square. Now this you can write root 3 plus I whole power 6 is equal to 64 I square. What is I square? Minus, you can get minus 64. Here there is no imaginary number, imaginary unit. Hence we can say this is purely real. Therefore we can say it is real. Therefore, if n is equal to 6, root 3 plus I whole power n is real. That's all. Likewise, we can find out. Okay. The other problems you will see in the next class. Thank you, children.